Hello again, welcome back to the same as O level live stream. So today we are going to start with make and manipulate matrix course in a Matlab, and I have found some new things, that is Matlab is also a sponsor, or you can say organizer, of different types of hackathons, competition and hackathons. Here you can see there are different types of hackathons and global competitions which are conducted or sponsored by the Matlab. So if we get sorry, if you go to the global competition, which is international level, you can see there are n number of competitions here which are conducted or organized by the which are sponsored or conducted by the Matlab. Here I want to take a participation in this, but the problem is it is in person, because I have to go to the Korea or United Kingdom, which I cannot because I don't have a visa. That's why. But I can go in this hackathon, which because it is in India at Telangana, which is nothing but in I triple no IIT Hyderabad. Okay, so when I try to search for different types of hackathon which can I attend online, I find this, that is Global Drone Virtual Competition 2026, and you can see the registration is over, and you can see the problem statement. We have to make a proper drone algorithm which will be given by the Matlab. In that we have to add or write a code where our drone can follow the light. This is a new topic for me, because until now I have only heard about the line follower robot, but I didn't heard of a line follower drone which can be in a deterministic environment, means a random environment, means there is a weather changing condition like winds or temperature which can affect the part of the drone, and we have to make a code which is does not depend on this weather condition or the temperature or any type of environmental problem, and then the drone has to follow the line and reach to the goal. This is a very new concept for me as an electronic engineering student, because until now I have only heard about the line following robot. You can see there, this is the track, that is beginner track, intermediate track, and this is the advanced track. And when I learn about the Matlab, I think that the Matlab is the best place. If you think that you know everything, just go to the Matlab, search for different types of courses and different types of hackathon, and you will know that how much you don't know about the technology. You can see this is a very good competition. I will take a participation in next year if Matlab will conduct this program again. Otherwise, you can see there are n number of programs which are sponsored by the Matlab. Here you can see in robotics, in programming, aerospace, automobile, data science, signal processing, and electrification. In signal processing, you can see the signal processing cup. This is also one of the most hyped hackathon in the Matlab. You can see it start at 4 to 8 May. Again, it is in a personal, means you have to present physically there to attend this hackathon, but I cannot go because it is in Barcelona, Spain. Although if I go there and I represent myself there, I will get a certificate which will be much more valuable than any Indian hackathon, because hackathon that are conducted outside the India has more value than hackathon conducted in India. Recently I have attended various hackathon in which I have used MATLAB Simulink, but I didn't won the first prize because the judges does not have that much higher IQ to understand what is MATLAB. Basically judges are person sorry basically the judges in these competitions are the person who just have ge- the the referral, or you can say the judges are not have the concept of technology. If there is something which is moving, or if there is something which is glowing, then they just think that this is a technology, but they doesn't know how does the technology work. That's why they didn't understand my concept. My concept is like tuberculosis detection from the phone, in which first I have gathered the data of tuberculosis from IEEE, where I have manually processed the signal in a MATLAB at 2000 to 4000 frequency, where I have used pass band and stop band for the frequency to pass from 2000 and stop at 4000. And again I have used a sorry uh, band stop filter there. So band stop filter will know the amplitude or the band of frequency which is above the amplitude of 50. So from this I have make an ML model which is which is based on an algorithm linear logistic regression. And from that logistic regression I have the value of weight and bias, and I have added that equation in my website, where the user will cough, or the coughing noise of the user will be gone into our phone. Then there will be a fast Fourier transform which will convert, then we will convert that fast Fourier transform into discrete Fourier transform, and after that the value of that discrete Fourier transform will go into our logistic regression model, and it will give us the probability of tuberculosis is present in the person or not. And I have shown that to a judge, but the problem that is the judge have have a very low IQ. That's why he doesn't understand what I'm trying to say. But I didn't won that competition, but I learned more about the MATLAB and more about the filters. In next hackathon, I have built a smart detection health detection system for the EV charging station, where the components will give the data to a node MCU. I have used a node MCU which is connected to cloud, and then the cloud is connected to a different types of node MCU. So in that node MCU, which is a receiver node MCU, so receiver have the receiver has a code of both HTML file and a Bayesian network. We have used the Bayesian network to detect the system health based on the poor quality data of sensor. So if the signal from diode or capacitor is weak, that means there is some problem. So Bayesian network will predict the total time failure when the system will go to failure mode because of that component, and also the total system health. But again the judges does not understand what I'm trying to what I try to say, and they give to prize, and they give a prize to a very basic level idea, which is nothing but a soil detection or soil moisture monitoring system, which I have done in my practical. Okay, but yes, if the judge has the IQ, then they will understand what I have made, because in VNIT I have I have taken a participation in a competition which is nothing but a project showcasing, where I have built a 6G technology, where I have built a I do not build the 6G technology. I build a encoder and decoder for the 6G technology based on the AI. So what will happen that the 6G waves are too weak, because the wavelength of each cycle is too much short, so they can be absorbed by the wall or any physical component. So what I did, instead of two digital level, or you can say DC voltage level, I have added 8 digital voltage layer. So the more data will be carried in that waveform, and then I have used a hopping frequency hopping, which will hop that frequency into different bands, and then the encoder will give the watermark to each band based on a time. So let's say for 1 hour the watermark will be same, but for another hour the watermark will be different, and this watermark is only recognized by encoder and decoder. So now the frequency will go to the decoder, but if the hacker try to emit some information in that layer, so what will happen, we will use two filter there. First is the digital filter, which is nothing but a bandstop filter. So what will happen, the frequency hopping will have a highest band, so the noise above that band, which is nothing but interrupted data coming from a hacker, will get stopped and we will receive our frequency. But the noise in that frequency because of the neighbor's band will be affect our data quality. For that I have used a logistic regression, again the logistic regression, and because of that logistic regression the noise will get reduced, and then the data will go to the decoder, where the decoder will know the frequency and the watermark, and it will give the data. If the frequency does not have the watermark, then the decoder will reject that frequency and we will get our data. So what will happen, the latency will be solved. So if one wave cycle is going to a decoder and another two beside that will absorbed by the wall, so the user have to wait for some time because of that latency. But if the single wave cycle has more data, then the packet loss can be negligible, like that. So for that we have won the first prize in VNID, because judges know that for this type of hardwares, first electronics, or you can say a company, has to do some research or some simulation, because without simulation you cannot build these types of hardwares. That's why we won the first prize. So that's the only first prize I have got in the hackathon, because the IQ of judges are matching with my IQ. That's why. So what I'm trying to say, that when I feel demotivated because I lost to a very basic idea in a hackathon, instead of I give my all to my project, then what will I have to do? I just go back to the Matlab. I see the courses, total courses here. I see the total competition. I saw the winners, which are basically 90% of population of 90% time the winners are from China. So it gives me motivation that why I'm comparing my idea to someone who don't know about the technology. That's how I motivate myself. So let's go back to the courses. You can see here is the course. Let's start the course.
Hello and welcome. Did you know that MATLAB stands for Matrix Laboratory?
Yep, I know.
Well, in this course, you'll dive into one of the most fundamental aspects of MATLAB, creating vectors and matrices from scratch or by manipulating existing arrays. Now, you might be thinking, can't I just use square brackets? Well, sure, you can type it out element by element. But automating this can make your programming faster. For instance, if you want to create predictable vectors or matrices, there are array creation functions for that. You may have seen some of these array creation functions in MATLAB OnRamp. In this course, you will learn more about how these...
So I know about the RAND because it is stand for random, and ones for only ones, and zero for only zero. But I don't know about I and line scale.
Functions work, and about more of these functions. Another reason you may not want to type out all of your data is because you already have it in MATLAB. That's where things get interesting. You could combine one array with other vectors or matrices, or reshape it into a new form.
This is called a manipulation.
You can also extract a submatrix or modify elements of your existing matrix without typing every single entry. By the end of this course, you'll be able to create and manipulate arrays with ease.
Okay. What will you learn? So today we will do only 20% of this course. Okay. Syntax, vector created and when to use. Syntax is uh, a into dx into b. So dx is nothing but a gap, and b is the end line, and a is the starting line. So lines for when you want a specific element spacing dx, then x equals to this for endpoints. When you want a specific number of element n. Okay, let's go. Create a variable name x that contain the row vector shown in the below. So what we have to do, we have to just write x equals to 3 colon 5, means we have to get the 2 and 11. All right, let's check. Oh shit, I have used a big X here. We have to use the small X. Yeah. Next, create a row vector name by y that start at 5. Create a row vector that start. So again, y equals to start with 5 and ends at 15. Create a new row vector that start at 5 and end at once. Okay, that start at 5, end at once, and the distance will be -1. Create a row that start with 0, ends at 12, and space by 5. Why are we are making this type of matrix? I don't know. Next, B. Okay, B equals to 0, start at 0, end at 1, and contain 90, evenly spaced 90, comma 1. There will be like 0 0.1, 0 0.2, like that. No? Okay, for this I have to use 0, comma 1, comma. Create a decreasing row vector name C that start at this. That start as this, end as this, and contain 20 evenly spaced sample. So again we have to use line space 3 into pi, sorry, 3 into pi, comma, minus pi, comma, 20. Which command creates a vector that start at 0, end at 100, and contain 50 evenly? This one. Next. Okay. Array creation functions. Matlab has several functions that you can use to create an arrays. For example, you can create an array of all zeros or an array of all ones. Okay, so I can create, I know that. The syntax for all of this function has the same basic structure in that you must specify the number of two and columns of the arrays. Okay, M is column and N is row. Create an array named X that has 3 and ones that has 3 row and 4 columns. So 4 comma 3. Is that wrong? Okay, sorry. 3 comma 4. Next, create an array name. Okay, so I don't know it will give the perfect answer or not. Yeah, it is giving the perfect answer. But what is the solution for this? See solution. Yes, I have done the perfectly. Create a column vector name xvec that has 10 elements where each column vector controls. So we have to use the column vector 1 comma 10, 3 into n. Yes. Oh, sorry, I have done the wrong. We have to use 10 first, then 1. Now it will be perfect. Next session. Create a 100 by 1 vector name xu of uniformly distributed random numbers. Create a 100 by 1 vector name xu. Control V equals to. So we have to use a random function here. Create a 100 by 1 again we have to use this. Create a 100 by vector name NX of normally distributed random numbers. So for that we have to use n here. So the function of rand is to have the random values in an array or a matrix, but the rand n means it will be a random number, but the difference between the numbers will be exactly same. Create this xi that that content contain uniformly distributed numbers integers with a maximum value of 6. So here we can make the in this function, which will I not pronounce. What does it do? It will create a random matrix or array, but here you can define that what will be the maximum number in this data, so it will not go about that number. Now use this function to create this vector of uniformly distributed random integers between this to this, name as this. Max 20, I mean 11. And using the this function, first input must be positive scalar integer. Okay, so here we do not have to give the comma, we have to just give the space. Eleven 20. Is this right? Yeah. First we have to give the mean, then we have to give the max. Use and to create this uniformly distributed random numbers between this to this. So what will we do? We will copy this data set, sorry, this code X. So for m and m, what we have to do, we have to write the name, sorry, we have to write the values. I need 100 rows but one column. Use a function to create this vector for normally distributed random numbers with mean, and stored vector is this. Control V equals to 5, which is nothing but a deviation, plus SD into I think we will get an error because SD is not defined. Yep, SD is not defined. So what, the mean is 100 and the standard deviation is, sorry, the mean is 100 plus standard deviation is 5. With this we have completed the 24% of the course. So we will meet, okay, 27% of the course. So after this video we will end the live stream.
Sometimes we need to analyze data that's stored in separate matrices. Here are 3 matrices of pollution data where each column contains pollution data for one day of the week. One matrix with weekday morning data, one matrix with weekday afternoon data, and one matrix with weekend data. If we want to find daily averages or weekly trends, we need to combine these matrices into a single matrix of readings for the entire week. Let's start with just the weekday readings. We need to combine our morning and afternoon data so that the readings for an entire weekday are in each column. To do this, we use a process called concatenation. We can concatenate matrices using the same syntax that we use to create matrices. The square brackets are the concatenation operator. They glue together the things that you put between them.
Okay.
Here, because the data sets are positioned top to bottom, we use a semicolon to separate them. That way, the 2 matrices get combined vertically, just like when we create a column vector.
Okay.
Now, let's add the 2 columns of the weekend matrix to the right of the matrix of weekday
Then we
data,
have to use
combining the
semicolon or
matrices
comma.
side by side. As you might have
Yes,
guessed,
comma.
we concatenate them horizontally using square brackets to enclose the matrices and separating them by a space or comma, just like when we create a row vector.
Okay.
What if we tried to combine our 5 by 5 weekday morning matrix with our 10 by 2 weekend matrix? Can you spot the problem?
Roar.
Well, to concatenate horizontally, they would need the same number of rows. And to concatenate vertically, they would need the same number of columns.
Then we have to add row
Since these 2
0.
matrices don't have the same number of rows or columns,
So there are 2 options. For first option is we have to create the remaining row or column of zeros, because zeros will not affect the whole matrix, and then we have to add that to in one matrix. And the second option will be, oh, there is no second option, I guess.
there's no rectangular matrix that could result from concatenation. So we get an error. The error message indicates that the matrices have inconsistent dimensions, which means that depending on whether you're concatenating horizontally or vertically, either the number of rows or the number of columns doesn't match. If you get this error, check that the dimensions are consistent and that you've used a semicolon for vertical concatenation or a space or a comma for horizontal concatenation. Even though the matrices have the same dimensions, that doesn't automatically mean concatenation is appropriate. In this case, both weekday matrices are 5 by 5, with columns representing Monday through Friday. We combine them vertically, because the columns match and each contains data for the same weekdays. The rows represent time, which increases as you move downward. You could concatenate them side by side, but now the rows and columns don't mean much. That makes about as much sense as saying 4 plus 2 equals 42. So when concatenating, make sure the matrices are compatible. Not just in size for the chosen direction, but also in what their rows and columns represent.
Yep. Okay, so there are 5 modules in this. So we will do it at evening, and that's all